In this video, I'm going to do these questions. These are 7 questions from probability, including MCQ, and 4 of them are MCQ. I've taken these four MCQ, out of which there are 7 questions altogether I'm doing, and this is for the standard class 10. Right? Let's begin with the first one. In this question from the chapter probability says a number x. So x is a number which is selected from these numbers. So x can be any of these 3 numbers, and there's then a second number y. So we are going to take y, and which is selected randomly, selected from these number, that is 149. And then the question here is that find the probability that xy being the product over here, right? The product over here of the 2 numbers is less than 9. It should be less than 9. So what you should do in the exam while solving this, you should first make a table like this. Let's say if I make a table, showing you the table over here like this. Well, x representing these numbers, 1, 2, 3, and y representing this. And let's find out the product over here. So if I multiply 1 with 1, we are going to get 1, right? So first row, first column, first row, second column, first row, third column. 1 multiplied by 4 is 4. Sorry, you can do like this. 4 multiplied by 1 is 4. 4 multiplied by 2 is 8. 4 multiplied by 3 is 12. 9 with 1 is 9. 9 with 2 is 18. And 9 with 3 is 27. Now check here, we have to get the product should be less than 9. In that case, less than 9 are what? These 3 are less than 9. This is less than 9. Even this is less than 9. So you can see that there are favorable observation, that is 5 of them is less than 9 out of total 9, right? It is less than 9. So these are the numbers which is less than 9. So the correct answer is option C in this case. Now in this question, it says the probability that a 2-digit number selected at random will be a multiple of 3 and not a multiple of 5. It should not be a multiple of 5. So first of all, you know that 2-digit number starts with 10 and ends with 99. To find out how many digits are there, 2 digits numbers are there, so it should be 99 minus 10, that is 89. But since both are included, you should know that we should add 1 to this. So one more time, first you get the difference and then add 1 to the difference when both of them are included. So we get to know that there are altogether 90 observations are there, the total observation. But then we have to find the favorable, and the favorable should be the multiples of 3 but not a multiple of 5. So in that case, you should make a table like this. Not a table, I should say. Write all multiples of 3. I've written already. And you have to discard those which are multiple of 5 as well. So 45, 75, 60, 90. So how many of them? 1, 2, 3, 4, 5, 6. Okay. And these are 7, 21, 28, 30. So 30 minus 5, sorry, 30 minus 6, right? 6, that is 24. So I mean to say that those which are multiple of 3 but are not multiples of 5 are how many of them? 24 of them. And you may count it. So when you find that, when you know that favorable is 24 and total is 90, then the required probability, right? Required probability will be the favorable, that is 24 divided by the total number of observation. It can be reduced 6, 6 4 times, 6 15 times. That is 4 over 15 should be the answer. We have an option B is the correct option in this case. In the next question, it says a letter is chosen at random from the letters of the word assassination. And then the probability that the letters chosen is a vowel is in the form of this. So they have already given the probability for selecting a vowel. And then we have to find the value of this variable x. So let's first of all, we should count the number of letters. This is 3, 3, 6, 3, 9, 3, 12, 1, 13. We have 13 as the total number of letters. And if I count the favorable, which is a vowel, even repetition should be taken. So this is 1, 2. A is a vowel I, A, I, O. So they are 1, 2, 3, 4, 5, 6. Yeah. So 6 is favorable and total is 13. So the required probability will be 6 over 13, and which is according to the question is 6 over 2x plus 1. So now it's very simple to calculate from here. That is, if I cancel this 6 by cross multiplication, we get 2x plus 1 is equal to 13. That implies 2x is equal to 13 minus 1, which is 12. From here, I can say x is 6. So yes, B is the correct option in this case. And in the next question, it says that an event is unlikely, right? Very unlikely to happen. Then its probability is closest to what? So what we know already that probability varies from 0 to 1. For an impossible event, the probability is 0, and for a certain event, the probability is 1. So the closer the values towards 0, the smaller is the probability, or very unlikely to happen. So what we have to find out here is that the event which is most unlikely to happen. So in that case, we need to choose the one which has the smallest value. So clearly this is the smallest. Even after by keeping more zeros, if you can not able to figure out, the smallest is this only. So the A is the correct option in this case. Now in the next question, it says the two different dices are tossed, and what we have to find out is the probability that the number on each die is even. So case 1 and case 2 is the sum of the numbers on sum of the two numbers is more than 9. So you should know that first we make a table for this is what the table we should make. This representing say dice 1 and this is dice 2. So these are the possible numbers that we can get. Now what is the first question here is the number on each die is even. So what are even? It has to be multiples, like both dice should be even, right? Each die even, so it can be 2 2 4 4 6 6, right? There should not be, because the 2 is the only even, and both even. Okay, fine. So it could be 2 4 2 6 also. It can be 4 2 4 4 4 6, and it can be 6 2 6 4 6 6. It's not about doublet, just finding which are multiples of sorry, which are even in both cases. So I can find out of the total 36 observation and how many of them are even. So 3 plus 3, 6 plus 3, 9. So the required probability is 1 over 4. For the first part, it's coming 1 over 4. Now check for the next. If I see the next one, what does it says? It says the sum of the numbers on two dice is more than 9. So more than 9 is what we can go like this. More than 9 is 30. This it's always easier to find from the end. This is 11 and this is 10, right? We cannot take 9 because it is more than 9 or not 9. So how many of them? 1, 2, 3, 4, 5, 6. So the required probability in this case is we got as 6 over 36. That's right. 1, 2, 3, 4, 5, 6. Yeah. So it's coming 1 over 6. So for the second part, it should be 1 by 6 as the required probability. Now, in this question, it says find the probability that 5 Sundays, right? 5 Sundays occur in the month of November. The month here taken is November uh, in an year, right? Selected in an year. So, what you know that in a month of November, there are 30 days. Now, out of 30 days, there are, that 7 days, and 7 into 4 is 28. Now, why I multiplied with 4? Because 4 is confirmed, like there will be 4 Sundays, 4 Mondays, and 4 Tuesday and all. Now, so we have to just find out what is the probability that there are 5 Sundays. So you can say that out of 28 days, in 28 days, there are 4 Sundays. Then we have to look for the 29th and the 30th day, right? So what are the possibilities for this? It can be Monday, Tuesday, can be Tuesday, Wednesday, can be Wednesday, Thursday, can be Thursday, Friday, Friday, Saturday, Saturday, Sunday, and then Sunday to Monday. And we will stop here because we started with Monday. Now, out of this 1, 2, 3, 4, 5, 6, 7, 7 such pair, right? Such pair is possible. And we need 5 Sundays. That means one additional Sunday. So we can see the Sunday is over here and over here. So you can see that these are two favorable, right? These are two. So out of 7, there are 2 favorable observation. So therefore, one more time, if you can see that here Sunday is over there in Saturday, Sunday, and Sunday is there in Sunday, Monday. So there will be 2 out of 7 is the answer for this. That is favorable observation is 2 and the 7 as the total observation. In this question, you see in a family of 3 children, find the probability that at least 2 boys are there. Now, this is similar to tossing a coin 3 times, right? So what we used to do, we used to say there are 2 outcomes. Over here, it's boy and girl. And the number of trials are 3 because the number of observations here in a family is 3. So we can say there are 8 such observation. So what you should do here, half of 8 is 4. So this is the trick. Write 4 times a boy. You can start with G also, and then 4 times girl. Then make it half. This is 4 here, right? So write 2 times B and 2 times G. Then again 2 times B and 2 times G. So you wrote 2 times and then next you write on 1 time. 1 time B, 1 time G. That's B, G, B, G, B and G. And what we have to find, at least 2 boys means what? 2 boys or more than 2 boys. So 2 or more than 2. So you can see that these have 2 or more than 2. As of now, I can see these have 2 or more than 2. And one more, this is more than 2. Clearly, we can figure out there are 4 favorable observation and total observation is 8. So 4 over 8, which can be reduced and written as 1 over 2.